Welcome back to inverse functions. We're going to start off by looking at the sine function. And remember, when we're looking at sine functions, we have to determine what interval we can keep a function so that it is a one-to-one correspondence. If I look at where this graph intersects a horizontal line, we can see that for any given period of sine, it would hit the curve twice, possibly 3 times, depending on where you have your line. So we're going to restrict the domain to the interval from negative pi over 2 to pi over 2. And we throw out all the other pieces. And we're going to include the end values. So what I mean by that is, do you see how I kind of put these brackets around the green highlighter for the interval from negative pi over 2 to pi over 2? The domain that we are going to keep is the domain from negative pi over 2 to pi over 2. Now if we look at the inverse function, you can see that the original function that I highlighted, and that's the portion of the sine function that was on the interval from negative pi over 2 to pi over 2. And what we did is we drew a line, y equals x, and then we reflected the sine function about this diagonal line. And that gives us the arc sine, or the inverse sine function. Now notice that when we reflect a coordinate point about the line y equals x, all the x values are now the y values, and all the y values are now the x values, which is why the rule from the previous video works that way. Consider y equals sine x on the interval from negative pi over 2 to pi over 2. Knowing that the domain and range of a function and its inverse switch, we just talked about that, and knowing that their graphs are symmetric with respect to the line y equals x, we can come up with a graph of y equals arc sine, or y equals sine inverse of x. The inverse sine function is also called arc sine and denoted by y equals arc sine x. Some instructors actually prefer this notation, and it will just depend on what your instructor decides to emphasize in calculus to determine whether they will use arc sine or they'll use just sine inverse with this little -1 notation. Now let's look at the definition of the inverse sine function. The inverse sine function is the function sine to the -1. That's just the notation we use for this reflection about the line y equals x, with domain -1 to 1 and range negative pi over 2 to pi over 2. Notice that previously, before we had reflected the sine function, the range was -1 to 1, and the domain, we restricted it, but the domain was 1 to 1 on the interval from negative pi over 2 to pi over 2. So we defined it to work as a 1-to-1 correspondence for that interval, and when we reflect it, then the range becomes that interval. Sine inverse of x equals y implies that sine of y equals x. Note that some instructors and textbooks will call the inverse sine the arc sine and denote it as arc sine, like this. So it's important to keep track of the fact that the notation is different, but what it means is exactly the same. Now let's look at the cancellation properties. We have sine of sine inverse of x equals x. Notice that when we looked at the sine inverse function, the domain is -1 to 1, and the range is -pi/2 to pi/2. In this case, we have sine on the outside, and the range for sine is -1 to 1. But when we have sine inverse on the outside, our range is from -pi/2 to pi/2. You will find this helpful when solving for angles within the functions, but also when looking at domain and range restrictions.